Our journey begins with this spectacular event known as a supernova. Picture this: a massive star, having exhausted its nuclear fuel, stands on the cosmic stage. With its energy reserves depleted, gravity takes over, causing the star's core to collapse under its own immense weight. This collapse triggers an immense explosion, a cataclysmic spectacle of cosmic proportions. This explosion, ladies and gentlemen, is what we call a supernova. The energy released in this celestial event is nothing short of extraordinary. To put it into perspective, a single supernova can release more energy than our sun will produce over its entire 10 billion-year lifespan. It's a cosmic light show of such magnitude that, for a brief period, it can outshine an entire galaxy. Now, supernovae are not just dazzling to behold, they also hold immense scientific importance. Astronomers around the globe eagerly await these celestial fireworks, as they provide crucial insights into the life cycle of stars and the workings of our universe. From our humble home here on Earth, we can merely glimpse the raw, untamed power of these cosmic explosions. Yet, even at such great distances, they offer us a front-row seat to one of the most dramatic events in the universe. A supernova is indeed a dazzling display that astronomers eagerly observe. Did you know that exploding stars play a crucial role in stellar recycling? It's a cosmic process that's as enchanting as it sounds. When a star meets its explosive end in a supernova, it doesn't simply vanish into the void. Instead, it leaves a lasting legacy, spreading its stardust across the cosmos. These supernovae are like cosmic alchemists, forging heavy elements in their fiery crucibles. Picture it. Deep within the heart of a star, intense heat and pressure fuse atoms together, creating elements like carbon, oxygen, and iron. Each of these elements has a story to tell, a story of birth in the scorching inferno of a star. But the end of a star is not the end of these elements. Quite the contrary. The cataclysmic explosion of a supernova sends these elements hurtling into space. It's a celestial spectacle that's as beautiful as it is powerful, a testament to the star's final act of creation. And what happens to these elements once they're out there in the vastness of space? They become the building blocks for new celestial bodies. That's right, the carbon in a distant star could be the same carbon that, billions of years later, forms a new star, or a planet, or even the cells of a living creature. So next time you look up at the night sky, remember, every star, every planet, every living being is part of this grand cosmic cycle of stellar recycling. These elements then become the building blocks for new stars, planets, and even life. And not all supernovae are created equal. You see, the universe is a vast stage, and supernovae are its most dramatic players, each performing a unique act in this cosmic theater. Firstly, we have Type 1 supernovae. These are the chameleons of the supernova world. They occur in binary star systems, where two stars are in orbit around each other. One of these stars is a white dwarf, a dense, dying star that's had its outer layers stripped away. This white dwarf pulls in material from its companion star. As this mass accumulates, it can trigger a runaway nuclear reaction, leading to a spectacular explosion. Moving on, we have Type 2 supernovae. These are the true heavyweights. They happen when a massive star, much larger than our sun, exhausts its nuclear fuel. The star's core collapses under its own gravity, and the outer layers of the star are blasted into space in a phenomenal explosion. Then there are the rarer types, like Type Ia supernovae, which are thought to occur when a white dwarf in a binary system pulls in so much mass from its companion that it reaches a critical point and explodes entirely. Each type of supernova has its own unique characteristics, contributing to the rich tapestry of our universe. Type 2 supernovae, on the other hand, result from the collapse of massive stars. What happens after a supernova explosion? This is where the story of exploding stars takes an even more fascinating turn. The colossal energy of a supernova explosion can leave behind a core. This core, depending on its mass, can take on one of two incredible forms: a neutron star or a black hole. Let's start with neutron stars. Imagine taking the mass of our sun, over 1 million times the size of Earth, and compressing it into a sphere with a diameter of about 20 kilometers. That's the insane density we're talking about with neutron stars. These objects are so dense, in fact, that a single teaspoon of neutron star material would weigh about 1 billion tons. But what if the core left behind is even more massive? Well, it collapses under its own gravity, creating a black hole. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape from them. They're like the ultimate cosmic vacuum cleaners, sucking in everything that comes too close. But don't worry, these celestial beasts are far from us and pose no threat. Instead, they offer a fascinating glimpse into the extreme states of matter and the powerful forces at play in our universe. Neutron stars are so dense that a sugar cube-sized amount of neutron star material would weigh as much as a mountain on Earth. As the aftermath of a supernova disperses into space, it leaves behind a beautiful and intricate structure. This fascinating artifact of a star's explosive end is what we call a supernova remnant. But what exactly is a supernova remnant? It's a celestial wonder that's formed from the ashes of a star's dramatic demise. When a star goes supernova, it doesn't just disappear. Instead, it leaves a lasting mark on the cosmos. The supernova remnant is composed of an expanding shockwave of gas and dust, an intricate tapestry woven from the star's fiery finale. This shockwave is a dynamic, ever-changing spectacle, continually sculpted by the forces of the cosmos as it interacts with the interstellar medium. Within this shockwave are the expelled elements from the star's core, elements like carbon, oxygen, and iron. These elements, forged in the heart of a star and scattered across the cosmos by a supernova, become the seeds of future stars, planets, and even life. Now you might be wondering, can we see these supernova remnants? Absolutely. And some of them are among the most famous objects in our night sky. The Crab Nebula, for example, is the remnant of a supernova observed by Chinese astronomers in the year 1054. Another stunning example is the Veil Nebula, a delicate web of gas and dust that's the aftermath of a supernova that occurred around 8,000 years ago. Some well-known examples include the Crab Nebula and the Veil Nebula. Exploding stars are cosmic gold mines, literally. These celestial fireworks, with their intense heat and extreme pressure, are the grand forges of the cosmos. During a supernova, atoms are squeezed together so hard that they form new, heavier elements. Among these are some of our most treasured substances, gold and platinum. That's right, the gold in your wedding ring, the platinum in your necklace, they didn't originate in a mine on Earth. Instead, they were formed in the heart of an exploding star billions of years ago and billions of miles away. The process is not easy, mind you. It requires temperatures so high that they are nearly incomprehensible to the human mind, and pressures so intense they defy our understanding. The supernova explosion then scatters these heavy elements across the cosmos. Over eons, these particles travel through the vast emptiness of space, eventually becoming part of interstellar clouds. These clouds, rich with the dust of dead stars, are the birthplaces of new stars and planetary systems. And here's the most fantastic part. Some of this stardust, carrying precious gold and platinum, found its way to our own planet Earth. It arrived here through meteorites, which peppered our planet during its early years. So the jewelry we cherish and the precious metals on Earth owe their existence to these spectacular cosmic detonations. Our final fact explores how supernovae act as cosmic beacons. These vibrant explosions are so luminous that they momentarily outshine entire galaxies. Such brilliance makes them discernible across unimaginable cosmic distances, effectively turning them into celestial lighthouses. But these beacons do more than just catch the eye. They're also invaluable tools for astronomers. You see, the light from a supernova takes time to reach us. The further away the supernova, the longer its light has been traveling. By observing this light, astronomers can calculate how far away the supernova is, giving us a yardstick to measure the vast cosmos. Even more fascinating is the role supernovae play in our understanding of the universe's expansion. In the early 20th century, Edwin Hubble discovered that galaxies are moving away from us, implying that the universe is expanding. But how fast? That's where supernovae come in. Type Ia supernovae, in particular, have a consistent peak brightness, making them excellent standard candles. By observing their apparent brightness from Earth and comparing it to their known peak brightness, astronomers can determine their distance. This in turn allows for the measurement of the rate of the universe's expansion, a value known as the Hubble constant. So the next time you marvel at the thought of these distant cosmic fireworks, remember, they're not just spectacular to watch. Astronomers use these distant cosmic fireworks to measure the expanding universe and unravel its mysteries. And there you have it, 7 explosive facts about exploding stars. In this cosmic journey, we've marveled at the spectacle of supernovae, delved into stellar recycling, differentiated types of supernovae, discovered neutron stars and black holes, admired supernova remnants, and found the cosmic goldmine. These celestial fireworks not only provide a dazzling display, but also help us unravel the mysteries of the universe. If you've enjoyed our astronomical adventure, remember to like, share, and subscribe for more out-of-this-world content. Until next time, keep your eyes on the stars.